Hello, and thank you for taking the time to watch this. My name is Tim Hogan with Made to Measure. In our last email, we introduced you to PAS Inspection Lifecycle Management, or ILM. We had a great response from it, but one question kept coming up. What is it? So as a very simple introduction to PAS, we put together this very short video to help explain what PAS is and how it works. It'll introduce you to how it can reduce your inspection time, which will increase your throughput and ultimately improve your bottom line. Now, PAS can be used with many different CAD programs, including SolidWorks, CATIA, and Pro-E. You can even use just IGES and step models as well. In this installment, we're going to be focusing on SolidWorks. We're going to take a SolidWorks model and convert it to a CMM program in minutes, not hours or even days. First, we're starting in SolidWorks. Let's go get our solid draw file. PAS has a module that works directly in SolidWorks. We are not in PAS right now, we're in SolidWorks. Now, with 2 clicks of the mouse, I'm going to balloon this entire print. 1, 2. While that's working through, you can see how fast it's actually going about it, and it's going view by view. How much time would this save you alone? Now, our entire print is ballooned. Now we'll go into PAS to start our CMM program creation. Let's save as PAS. 1, 2, 5, 9. Just something unique. Now it's going to go directly into PAS and open the model, the solid model that was associated with the solid draw model. Now those of you who are used to SolidWorks know that when you put dimensions on a print, on the model, they're called annotations. When we look up here in the tree, we can see annotations right here. And if we click on the different drawings, we can see that these are the views that came over from SolidWorks itself, along with all of the balloon numbers. No need to have to re-balloon it. Now, we need to tell the software how we're going to set the part up on the coordinate measuring machine. As you can see from our trihedron here, X is running from here to the back, and then Y is running off to the side. But how we're going to set this up on the CMM is we want X to come off to the side and Y to be toward the back. We do this by setting the coordinate system. We simply right-click on the part and say Part CS. CS stands for Coordinate System. Now we simply select what we want to use for a 0. For those of you used to CMMs, this would be similar to your manual alignment. Now we're going to set the Z and then set the X. But not to be confused with the datums. The datums are brought over from SolidWorks and they are measured and analyzed independently. This is simply just to set the part up on the machine itself. We say OK, and now our coordinate system, X is going to the side and Y is going to the back. Now that we have our coordinate system established, we need to create a process. This simply tells the software, start making a CMM program. The window that pops up needs a couple of different inputs, machine and part. The part is what it already used. Machine is the CMM. You'll see many different CMMs available because PAS can export to any DMIS-based language, so it can run on a variety of machines. It is not limited to any one brand. For the sake of time, we'll just leave it as it was last time. This brings in our machine and our part. We can use the scales to move the part around as best we want to. If you have a small machine with a small measuring envelope, it's more important to get it set properly so as to avoid collisions. In PAS, we work on collision prevention, not collision detection. If you have a large CMM and the part fits in, it's not as important. Now the machine is still there. We can see it up in our tree. However, we've hidden it just for simplicity. So now we have created a process and we need to extract features now. What do I mean by that? Well, in SolidWorks, we told it what we wanted ultimately, meaning we want this distance, we want this diameter, we want this position. However, when a CMM goes to measure that, it needs to know whether to measure a plane, a circle, a cylinder, or whatever it is. We do that by extracting features. We simply click on our part and hit extract. What types of features are we looking at? You can see right here, planes, lines, holes, bosses, chamfers, all that good stuff. Preferences is a very beneficial area. What it does is it allows you to avoid insignificant features. For example, maybe small chamfers like are on right here. Or maybe these small fillet radii, which are just for clearances. We don't want to measure them, so we ignore them. Anything smaller than a certain amount, it'll just simply ignore. Axis increment is simply what our head angles can rotate to. We say OK. Now we have colors. What are we looking at? Up here in the top left on our tree, we see 0, 0, 90, 180. These are our tip angles. If we click on any one, it shows us all of the features that will be measured with that tip angle. If we want to select a different angle, for example, maybe we want this surface to be measured with the 0, 0 tip. We simply select that surface by clicking on it, right-click on the surface we want it to be attached to, and hit attach. Right-click and hit attach. Now, that surface is attached to that and will be measured with the 0, 0 tip if it needs to be measured. Now, we can go look at our CMM code. Do we want to inspect? Absolutely. That's what we're here for. Two features could not be expected. That's very likely. Probably because of clearances, or it couldn't access the features. We can see all the probe points that it's being used. It says it could not be inspected. We can see 2 failed right up here. Yes, we want to continue. Now, any surface we mouse over, we can see the probe points for that surface. We can alter those probe points or just leave them as default, whatever we want. But we can see here in our CMM code window, we're set up for PCDMIS. If we hit View, here is our CMM code. Those of you used to programming CMM will know what this looks like. We have already created our CMM program from our CAD model and from all the annotations that we put in SolidWorks. This right now is ready to go over to PCDMIS and be executed. When we hit parameters, I mentioned before that PAS can export to a variety of programs. You can see here mCosmos is Mitutoyo software. PCDMIS is a software for hexagon metrology machines. OpenDMIS can run on Wenzel machines. And other softwares as well that are DMIS based that may or may not be supported now can still be used. So you can really give your old software a new lift. For this installment, we'll stop right here. PAS has many other features, including, for example, simulation. And we're just scratching the surface. We would be more than happy to do an online presentation with you using your parts and models. Please contact us to set it up. Again, this is Tim Hogan with Made to Measure, and I thank you for your time today.